Hello everyone, my name is João Victor Bolson Marques. I am a master student at Universidade Federal de Santa Maria here in Brazil. And today I'm going to present to you our study named Module of Contrastive Analysis for a Phonological Assessment Software in Development. So first I'm going to give you a small introduction about our subject. Then I'm going to talk about the contrastive analysis, which came from the speech therapist field. And then I'm going to talk about the proposal to finish the presentation with our conclusions. So currently our research group is working on the development of the digital platform called the Phono. This platform aims to facilitate the application of phonological assessment in children and assist the speech therapists in data analysis. It is also composed of a mobile app, which is used mainly to collect data from the from the phonological assessment. A web services where the speech therapist can go and access all of this data and generates all kind of reports, and a REST API to integrate the both services. So here we have a basic flowchart of our application. We have a set of target words here that must be spoken naturally by the child. All of the pronunciations are stored in audio files in our database, and the speech therapists do the phonetic transcriptions of these pronunciations. We have here a lot of internal processing, and one of these processes now is the module of contrastive analysis. So here is our mobile app. This interface is very simple and user-friendly. So when the child sees this image, she is asked, what animal is that? And then she must speak naturally the word that represents that image. And the pronunciation is stored in our database. So the speech therapist now can go to the next word. Here we have a set of 84 words, so this number will be important later in our presentation. So let's keep it. Here is a basic architecture. We have three layers here. The mobile app, where all the phonological assessments are performed. The web services here, where the speech therapist can build new modules of phonological assessment and has access to the data collected in the mobile app. Here we have a REST API that includes all the functions that we implemented. So let's go now to the contrastive analysis. What is this? So basically, it's a comparison between a valid transcription, an expected one, by a given transcription from the child. So instead of just classifying this transcription here as incorrect or invalid, in the contrastive analysis, we are interested in go deeper in this analysis and identify in what region of the word the error happened. If it was in the beginning of the mid or in the middle or at the end of the word, the pronunciation, and what phonemes were involved in this error. If it was a substitution or the child just removed the phoneme. So this is the contrastive analysis. Here we have implemented flowchart. So here is basically our mobile app layer, which is used to perform the phonological assessment. And here we have the contrastive analysis. So the first step here is to split all the phonemes from the transcriptions and classificate each of these productions here as correct, omission, or substitution. We use this classification to calculate the PCCR, which I will explain to you in the next slides. And here in parallel, we have the obtention of the phonetic inventory, which is basically a set of all the phonemes that a child can articulate. So here we have the PCCR. So to calculate it, we count all the correct consonant productions. So here would be just two correct productions, and we divide it by the total expected. So, for example, if the child wasn't able um, to even to even reproduce at least 50%, so the indication of disorder will be high. So this here is just an indication. It is not a diagnosis or a final decision. This is just an indication of disorder. So we should pay attention to that page. So the phonemes analysis here in the contrastive analysis, we basically have a template here, which is the their expected transcription, and we have the transcription from the child. So we compare them, and we have here the productions, the substitutions, and we count each of these productions here in a table to calculate the PCCR. So to have the phonetic inventory, which means all the phonemes that a child can articulate, we just count all the productions. We are not interested here in knowing if this production here was correct or it wasn't expected here. We just want to know if the child is able or not to reproduce that phoneme and build the phonetic inventory here. Uh, so all of this process is done manually. Currently, all this process is done manually with paper and pencil by our speech therapists. They use a lot of spreadsheets, and no similar tool were found supporting Brazilian Portuguese with these features. So let's go now to our proposal. So the main challenge here is to identify the exact position of each of these productions here, to know if this phoneme here was at the end of, at the middle of the word, but in the final of the syllable, or is just in the middle of the word in the beginning of the syllable. That is different positions. So how can we go to this here, I split transcription from this? So maybe here we should replace the vowels by spaces and then split the transcription by spaces. Yeah, but this is a problem when we have a transcription like this example here. We have we this must be separated. This is a phoneme that is in the middle of the word, and in the end of the syllable. I'm sorry. So the solution it was using a case-based approach, which is the Levenstein distance algorithm, to obtain the most similar case with the given transcription. So first we look to all the known cases when we receive an entry transcription. And if this transcription here is in our database, we already know exactly the contrastive analysis for this transcription. So we have already done this. If don't if not, we look for the most similar transcription using the Levenstein distance algorithm, and we just need to compare them one above another, and we have like this the contrastive analysis. So to calculate the phonetic inventory and the PCCR, we just use the same logic, because we just need to count each of these productions here. And we have now the phonetic inventory and the PCCR with the indication of speech disorder. So let's go now to our prototype. So this screen here, all the contrastive analysis is a process that is done after the phonological assessment. So this screen here is the web service, is at the web service. for each of the transcriptions. So at the first look, maybe it looked like weird for us, but this screen here is based on the spreadsheets that is used by our speech therapists. So we are not interested here in changing the way they work currently, because we are just interested in get something from the real world, the manual process, and put inside a digital platform. So this is our contrastive analysis view in the web service. And all of this information here can be edited by the speech therapist. So this information is generated automatically by our module, and the speech therapist doesn't need anymore to generate all of the contrastive analysis from scratch. He just needs to check the information and maybe correct something if the system presents some kind of errors. So here is the prototype of the phonetic inventory here, where all the phonemes that the child can articulate is presented. And here is the screen with all the patient information. Here we have all the target words received, the transcription and the computer classification and human revision. This computer classification here is not the scope of our study today, but it is just a computer classification for this entire transcription here. We in our study we're interested in go deeper in this analysis here, but this is not the scope today. And here is the calculated PCCR, which is calculated even if the speech therapist edits something in the platform. Um, and it is important to remember as well that we have a set of 84 words. So the contrastive analysis is done inside each transcription. So when the user finishes his assessment, the contrastive analysis is already done. So the speech therapist doesn't need anymore to do all the contrastive analysis, all that process manually from scratch. He just needs to check some information if it is valid or not. So the entire platform is being built with the help of our speech therapists. So we are not interested here in changing the way they work. And we already receive a positive sign about the system compliance with the challenges faced in the real world. So it is very similar with the spreadsheets they use. And the complete platform included in proposed module should be tested and validated in the coming months to collect feedbacks and improve even more the system. I'm sorry. With the automatically generated contrastive analysis, it is expected to reduce the time spent by the speech therapist on an assessment because it is all done automatically now. So the module allows you to correct information in case of errors, as I said, and it is a less expensive work to verify and check the information than to generate it from scratch. With the phonetic inventory available on the platform, the speech therapist can focus their future work with the patient in phonemes that have not been yet acquired. So after complete validation, we'll be able to release it to the interested parties and the general public. We are also studying the possibility to open the source code to anyone that may be interested in using our system or doing some contribution. And we are also studying the possibility of developing a new plugin for the phone software, which is a software mainly user for mainly sorry mainly used for studying the language for of linguistics. So it has robust functionalities but it lacks a more user-friendly implementation. So maybe we can do some contribution in the future for this software. So here is some of my reference, and that's it. Thank you all. Bye.